Megan, here we are at the Sea Air Space Conference from the Navy League, and the theme this year is Campaign Forward. What do they mean by that?
The National Defense Strategy has been released in its classified form, but its upcoming release in an unclassified form, and really what's being previewed here at Sea Air Space this year is the notion of campaigning forward, which is a maritime strategy where we don't just have ships and aircraft and personnel out and about for no reason. They're really focused on being at the exact right place at the exact right time to provide the best deterrent against China. So the idea of campaigning forward is really sort of synchronizing all the forward presence to make sure that the forces that are available are used as smartly as possible.
And China is a big country that has ocean, but a lot of it is landlocked. Are there areas that are the best areas that they're kind of focusing on right now, or is that kind of up in the air?
It's really the South China Sea. Obviously, like you said, China is a large country, but where the military assesses they pose the greatest geopolitical threat is really sort of their behavior towards their neighbors in the South China Sea. So the idea behind campaigning forward and other deterrent strategies is to say the Navy should be in China's way. If they want to be aggressive with their neighbors, the Navy should already be there and be watching them and prevent it from happening if possible, and if not, be there to monitor, record, and really expose to the world what's happening in those contested areas.
And in terms of technology and systems being developed, one story you had was on laser weapons, on directed energy, and Northrop Grumman was asking something kind of interesting that maybe instead of them making the entire systems for the Navy, is they kind of want to outsource parts of it. Tell us about that.
Yeah, so there's a new acquisition strategy that they're working with the Defense Department to kind of propose. And the idea is that under this acquisition strategy, you would have one kind of prime contractor, but you would have subsystems. So one company might work on the battery system, one company might work on cooling, one might work on the interface between the laser itself and the combat system on the ship. And the idea is to really create expertise within industry, but also to create more suppliers that have familiarity with laser weapon systems. Right now, the companies are really only kind of building these in a one-off fashion, since it largely remains a research and development project. But once the services get into acquisition, they're going to have to be produced in much larger numbers, and industry just can't do that right now. So this approach would bring many more companies into that supply chain.
And what other kinds of technologies are we looking at? I've heard a lot about autonomous ships.
The idea, for the Navy at least, is that autonomy shouldn't be a thing in and of itself. It should be a tool to enable other missions to take place. So the Navy's really looking at AI, machine learning, unmanned systems as a tool to supplement, manned ships, manned submarines, manned aircraft. But how can they take systems and maybe find the best targets, maybe find the smartest way to do maintenance, kind of identify needs before they occur, take away some dull, dirty, dangerous missions away from manned craft and offload them onto unmanned. So the Navy is really viewing these as tools to help them achieve their ends that they have, rather than something to be kind of looked at in a bubble.
And you mentioned AI, artificial intelligence. It's a lot of different companies working on it, a lot of computer companies, and a lot of people are trying to get on it right now. What's kind of the next step for that the Navy wants to see?
I think they're really just looking, there's kind of a joke about, AI being a buzzword, sprinkle a little bit of it here, sprinkle a little bit there. They really want to sort of have a strategy that looks at how AI is being implemented. The Navy actually has an unmanned task force that was stood up at the Pentagon, and that's one of the issues that they're looking at, is how, in a smarter, kind of holistic way, they can look at technologies and enablers such as artificial intelligence and figure out how to apply them, how to acquire them, how to bring in industry, and really a pre-planned kind of smart approach.
The Navy is a growing service and it's really advancing. One interesting story you had was that they're decommissioning some of the ships. What's going on there?
The Navy is actually on a path to decrease by about 18 ships over the next 5 years, which sounds counterintuitive when you think of all the threats around the world, particularly China as the pacing threat, and their Navy is growing so quickly. However, the point the Navy is trying to make in their FY23 budget proposal is that the Navy doesn't need to be larger, it needs to be more ready, and it needs to be more lethal. So what we're seeing here at Sea Air Space is a lot of proposals for how to make the Navy more lethal, whether it's looking at future weapon systems, whether it's looking at enablers to help sailors do their jobs better, but really just focusing on having a better fleet rather than a larger fleet.
Well, Megan, you're a super busy person. Thank you for carving out some time for us.
Thank you.
Doug, we are beneath a scale model of the Triton, which is currently deployed with the U.S. Navy. It's an autonomous vehicle. Can you tell me a little bit about it, please?
Yes, Triton now for the U.S. Navy, it's a high altitude, long endurance platform. Can fly 24 hours a day. Its altitude's greater than 50,000 feet. And what that does, the value proposition there is it can see a large range, see a lot of targets on the ocean, and truly understand the intent of what every vessel is doing on the ocean. So autonomy is really the only kind of technology you can employ on this kind of system.
And that's the big highlight of this one, that it essentially flies itself and sends information to a ground station, if I'm getting that right.
Yes.
What makes it so that it can last a lot longer than a manned aircraft with people inside of it?
Well, the idea there's no personnel in the air vehicle, right? So it actually takes 3 crew shifts to manage one flight of a Triton. But what keeps it out at altitude, you can see the wingspan, large as a 737 wingspan. That provides more like a glider type airfoil. And with the engine at high altitudes, it can stay up for hours of 24 hours at a time. So all that information, it is flown autonomously. All the information and data transmits over satellite to a ground segment where there's operators, analyzing the data and disseminating that across to all the warfighters to truly give maritime domain awareness to the operators.
And I imagine the suite of sensors it has is probably different for every plane, or what they order?
Well, for the U.S. Navy, we have electro-optical infrared sensors for imagery. We have an MFAS radar to detect the vessels on the ocean. We also have AIS to give understand what those vessels are. So, and we also have SIGINT payloads on here too. So the combination of all those sensors with all that information coming to a ground station fused together can provide total situational awareness to the operator.
And this aircraft flies itself. How does it know where to go?
It flies itself. So there are predetermined mission plans, but during a mission, an operator can give it new waypoints, and it can route itself in different directions.
And the technology is not only in the Triton; it's also in a more familiar aircraft, I believe a helicopter.
We also have an unmanned autonomous helicopter built off the Bell's 407 aircraft, and that's currently deployed off of the littoral combat ships.
This is a very advanced aircraft, but I can't imagine that it stops right there. What's the next step in advancing the technology of this?
Right, the configuration is currently deployed. As I said, it'll collect a lot of data. So now we need tactical decision aids to go help the operators on the ground to really sift through that data, and through machine learning also understand patterns of life to really provide the best value to the warfighters so they can make their jobs more efficient as we go forward. So they're the technologies we're looking at as we move forward.
Well, Doug, thanks for having us over.
All right, thank you.